everyone. In this video, we will be learning about what is population, what is sample mean and what is population mean, and also its importance. So let's start with population. So what is population? A population is the area of our interest of distinct group of elements. So what do I mean by that is, suppose I want to get the average salary of all the people in a particular country. Okay, country. So I want to get the average salary of all the people in a particular country. So suppose in that country there are 1 million people. Okay, so these 1 million people, they are my area of interest. They are the area of my interest or area of my experiment, right? So they are called population altogether. So in order to perform this thing, what we need to do, we need to go and check each and everyone's salary in this particular population. Okay, so on and so forth, 1 million. Okay, and then we will have to take the average of that in order to get the average salary of all the people in a country. So what will be the formula? 1 divided by 1 million, summation of I is equal to 1 to 1 million, because we are considering 1 million people are staying there in a country, and their salary, sum of their salary, right? That will be the average of the salary of all the people in a country. So this is my population, this 1 million people. Okay, now let's move on to what is population mean. So as I said, population mean is nothing but the average of that population or whatever we are trying to find out. Suppose in that country, instead of salary, now I want to find out the average height of all the people. Okay, then the population will be all the people and their height, all the 1 million people along with their height. That will be my area of interest, right? That will be my population. So what is the population mean? It's nothing but the average of that population. So as I told you, the formula will be 1 by capital N. Here N represents the total number of elements under this population. For our consideration or for our example, that will be 1 million here, right? Because we are considering in our country 1 million people are staying, and summation of X, whatever we are, this X is our variable. So this can be height, okay, this can be salary, this can be age, or anything, whatever we are interested in. So that is what population mean is. Now let's move on to sample. So what is sample and why do we need sample? So now imagine a situation where we need to take the average salary of all the people in the country. So is it really practically possible to go and collect everyone's salary in the whole country? Is it practically possible to deal with the whole population? Practically possible? No. The answer is no. Because for our example, we are considering it's 1 million. It can be 10 million, 50 million. We don't know the amount of data we are going to handle with, right? So that's why handling with the entire population is really impossible. Rather, what we can do, we can randomly pick some element from our population, and then we can check what is their salary and take the average of that particular random selection. Okay, so these particular things we are selecting and we are creating a sample out of it. Then out of that sample, we are checking what will be the average height or average salary or average age of this particular sample. So a sample is nothing but randomly chosen data points from the population. So if this is a population P, a sample S will be a subset of that population. Now we can take multiple samples as well. Sample 1, sample 2, sample 3, and there are different ways of selecting samples. So we will also be discussing how to create these samples, what are the different techniques of creating these samples in later videos. Okay, so that's how we create sample, and that's why we need sampling, because we cannot deal with the entire data of a population. It's very, very huge to handle. So that's why we go for sampling. Now let's come to sample mean. So sample mean is nothing but sample mean is represented by either mu x bar, or it can be represented by x bar. The nomenclature can be anything. So this can be represented by either this symbol or this symbol. And the mean is nothing but the average of that particular sample, whatever variable we are handling. If it is age, then it is age. If it is salary, it's salary, whatever we are interested in, right? And the standard deviation of the sample mean would be this, sigma divided by root under root of n, where n is the number of data points in the sample. In the sample. Okay. So this n value, this will always be, this n will always be less than capital N. Why? Because this n is the number of data points of population. Okay. And now if I talk about standard deviation, so I will discuss about standard deviation in later videos. So here, this standard deviation is representing the standard deviation of the sample, and this sigma is representing the standard deviation of the population. Okay. So now, what is considered to be a good sample? So as I told you, there we can select multiple samples out of a population. Now, what is a good sample? So for that, let me take another example. Suppose I want to understand the average salary of all the people in a country. Okay. And as I told you, we are going for 1 million people in the country. So this is our capital N. And from here, this is our population. Okay. And from this population, we have created, suppose, 3 samples. This is one sample 1. This is sample 2. Okay. And this is sample 3. Okay. So now my agenda is to find out the average salary of all the people in the country. And because it is not practically possible, let's just say that we are taking random samples and we are taking what is the average salary of all the people in sample 1. Okay. And suppose it is 30,000. Okay. Now this is suppose around 60,000, and the average salary of sample 3 is suppose 55,000. Okay. Now, if by our survey we are getting this, the salary of, now if we take the salary of all the people of the country, okay, we take the average of all the people of the country, the average salary of all the people of the country, then suppose it is coming around, okay, 47,000. Suppose it is coming around 47,000. So out of these 3 samples, which sample is representing the actual value? I mean, near the actual value, which sample is doing so? So it is our sample 3, right? Because sample 3 is showing us that the average salary of all the elements in this particular sample is 55,000 average salary. Okay. And these 2 are not near 47. So which sample is showing the nearer value? That is sample 3, right? That is where we are saying sample 3 is the better sample as compared to sample 2 and sample 1. So if I talk about the definition of a good sample is said to be that particular sample which can closely represent the population, or which can closely represent and capture the variation in the population. Okay, that is considered to be a good sample, right? So as I told you, we have different sampling techniques by which we can get the best sample. There can be different scenarios for different sampling techniques. We will be discussing about different sampling techniques in the later videos. Now, when to use what? What do I mean by that? I want to mean when to use population and when to use sample. Okay. Mostly population is very huge. So practically we never deal with population data. Okay. Because it is really very impossible to handle that huge data. That's why we normally don't go for population data. We always take samples from population. Okay. And then we do the analysis on that. We make hypothesis out of those samples. Okay. And then we conclude whether the hypothesis is correct or not about the population. Okay, that is how the overall cycle is. Okay, so now if our population data is really small, okay, then we don't need to go for sample, because sampling means we are choosing few data points and eliminating few data points. Now if my population is really very small, then at that point if we eliminate few of the data points, then we are losing our information. So in that case sampling is not a good option, but that is a very rare scenario. So suppose, let me give you an example of suppose in a class there are 30 students and you want to understand what is the average mark they are getting in mathematics. Okay, so for that the data points is very simple. So you don't need to go and do sampling on this particular 30 students and then do the analysis or do the mathematical computation, right? That is not required here. So if you are dealing with that kind of data points where the original number of data points are really very small, you can easily handle those data points or that much data, then you can go for population data. But practically we don't deal with that small data. That's why it is always recommended to take a proper sample from the population, then do your analysis, perform your hypothesis, and conclude. Okay, that's how we do it. So with that, we have come to the end of this video, and I hope I have made it clear what is population, what is sample, how to calculate sample mean, and how to calculate population mean. We have also touched the point of standard deviation of the sample, but we will be discussing about standard deviation in later videos in details. Also, we will be discussing about sampling techniques, different sampling techniques. So stay tuned for further videos.